All right. So we've got two numbers, A and B, in our set.
Somewhere.
And C is any integer. And if A equals B times C, then C has to be in the set. Okay?
So we know that if...
So, yeah. Why don't we do the examples right at the top? I'll erase family math. Okay, go ahead.
So, we could do something like, with using 1 again, we could use, like, the first one we could do 4 equals 1 times 4.
Okay.
So, for this, it works because since C and A equal each other, then C is an O.
Okay, so if B equals 1, it's definitely true.
Or if B equals A, it's also true.
Why is that?
Because then C would have to equal 1.
Okay.
And C. So,
Alright, so there's one sort of, we've checked some simple cases.
yep.
So, well, the one that I see is 16 plus 4 times 4
Okay.
is one that works. A and B are both in the set, and then C is also in the set.
Okay, good.
So next one, so there's 16, 19, and then 22. And 25. Well, not a lot of these numbers actually factor in the set.
Well, you
So
have,
most of them look like this.
you could do 28 equals 4 times 7. That would also work.
Okay, good. So you're starting to be able to find some examples. But if we were going to try to do this with an exhaustive list of examples, what would the problem be?
There might be
It's an infinite set.
It's an infinite set, yeah. So now that we've seen some examples where it works, we've got to move to the next step.
We'll just generalize it.
Yeah.
So we know that. So we know if A equals B or A equals C, it works, and we know if A squared or B is the square root of A, it also works.
Okay.
And they're both integers, just that one.
All right.
But how would we do it generally? Because just from looking at examples, it appears that either it doesn't factor within the set or it factors within the set. It doesn't factor half in the set and half out of the set.
Right.
So well, maybe we can look at. We could look at something since maybe the numbers go by 3 every time. Maybe we can look at something having to do with mods.
Ah, interesting. Okay. So, yeah, this is an important first step in the generalization, is what you just said. It's understanding the set.
Yeah.
That's a very important first step, and probably actually is the first step. So what is this set?
Well, it's you're starting with 1 and you're adding 3 every time.
Okay.
So the nth term is going to be 1 plus 3 times n minus 1.
So
Okay. So
the first term.
how could we describe these numbers in a very simple way?
they're all 1 mod 3.
These are all the numbers that are 1 mod 3. Okay.
Well,
So from that
I think I sort of see how you could do this now. So if A is 1 mod 3, both other numbers, they can't be 2 or 0 mod 3 because.
Well, we know more than A is just 1 mod 3.
And we know B is 1 mod 3.
Okay, I'm switching out your marker for you.
So.
Okay,
then,
we know A is 1 mod 3, and we know B is 1 mod 3.
So we know we have this equation. So 1 equals 1 times something, and that something has to equal 1
Okay, why?
because that's the only value that works out of 0, 1, and 2.
Aha.
So that means that C is 1 mod 3, so C is in the set.
Okay. So it was very difficult to try to approach this problem without understanding what the set was.
Yep.
But that's when once we understood the set, what happened?
Pretty easy.
It was actually pretty easy. Okay. All right, very good. So let's go on to the next part of this problem.